Okay. Our second awardee is Dr. Jason DeCruz. He's somewhere in our background here. He's an associate professor of philosophy at the University of Albany in SUNY. Jason works primarily in ethics and moral psychology, focusing on topics of trust, trustworthiness, self-deception, and rationalization. He has published work that appears in Philosophical Studies, Ethics, and the Journal of American Philosophical Association. And his award is for a proposal entitled Trustworthy AI from a User Perspective. So, Jason, it's all yours.
Great. Well, thank you for the hosts for bringing together such an august group of speakers and such an engaging group as well. I'm just making sure that, there we go, that my screen sharing is working here and that the slides are full screen. Okay, so our project develops the foundations of a trustworthiness assessment framework for AI-driven systems. And we propose to develop the conceptual foundations of a system of metrics that foregrounds context, user experience, and human priorities. And in this aim, we are proposing two novel characteristics of highly trustworthy AI systems that we dub reciprocal trustworthiness detection and trustworthiness. Since I just have a few moments today, I'm going to focus on rich trustworthiness. So I should say that our aims are primarily conceptual, and they're aligned with our expertise in moral psychology, in theoretical and practical rationality, decision theory, trust theory, and social epistemology. But our ambition is that in collaborating with AI and ML designers and engineers, including specialists in human and computer interaction, our work will have a downstream effect on the conceptualization, the design, and the implementation of AI systems. Okay, so on the slide over here, on the top right, you see an image of DigiDog, and DigiDog is a semi-autonomous robot deployed by the NYPD very unwisely in a public housing project in the Bronx, where distrust of the police is already very high. And needless to say, DigiDog was not well received. It was seen as a dystopian example of over-aggressive policing. And the NYPD turned DigiDog to its maker, Boston Robotics. And so one question we might ask is, what changes to DigiDog could elicit a trusting response from citizens as opposed to the distrusting response that it did receive? And a sort of surface fix would be to do to DigiDog what you see on the bottom right hand of your screen over there. That is to make DigiDog appear more lovable, like this huggable Newfoundland. Give DigiDog some fur. And that would be a sort of surface fix to the trust problem. But the deep fix would be to ask much harder questions like, how might citizens come to know DigiDog's capabilities and limitations? How might they come to know its assumptions, its motivations, and how might its behaviors become legible to them? How would DigiDog or its human partners be held accountable for their actions? And these are the hard questions of trustworthiness. And the deep problem is really not in maximizing trust. Maximizing trust really should not be our aim. The deep problem is in matching trusting attitudes with trustworthy systems in the appropriate domain. And that's what we're going to call well-calibrated trust. Okay, so the idea is that resilient trust that endures, requires matched trustworthiness. And the experience of trust that is not met with trustworthiness creates a generalized distrust. And we have got some good empirical evidence of this. So when a person loses their ability or their confidence to reliably discern trustworthiness, they lose their self-trust. And when a human user loses self-trust, then the trust relationship between the human and the AI system is broken. So the question is, how do we address this problem? And how do we implement a solution in AI applications? So one idea that we have that I'll speak briefly about is this idea of rich trustworthiness that we borrow from the philosophical literature, and in particular, my colleague and collaborator at the University of Melbourne, Karen Jones. So first thing to notice is that no finite agent, whether a human or an AI, can be competent in every domain. Therefore, trustworthiness is necessarily indexed to domains, to tasks, and to parties. Now, as agents with finite information and finite time to search for more information, we need collaborators who are willing and able to identify themselves so that we know where to place our trust and for which tasks. That is, we need agents that are not only trustworthy, but also richly trustworthy. A richly trustworthy AI system must be able to continuously monitor and assess its own dynamic functioning. It must be able to generate signals that are legible to both human agents and other AI systems about what it can be trusted to do. Rich trustworthiness is a step beyond comprehensibility in that the AI system is tasked with producing accurate signals about exactly which dependencies it can and cannot respond to. The trustworthiness of AI systems does not guarantee that humans will trust in such systems. A trustworthy AI may not be trusted because its trustworthiness is not legible or credible to a human user. Conversely, AI systems may win the trust of humans even if they're not in fact trustworthy, but only appear to be so. Human trust in AI systems may be misplaced. Rich trustworthiness in an AI system encourages trust that finds matched trustworthiness because it invites trust only where there is competence to respond to human dependencies. And as a result, rich trustworthiness is more robust and ultimately, we think, more resilient. Got any questions or would like to be in contact with us, here are our email addresses, and I'll throw it back to Dr. Doorman.
Great. Thank you very much. Yeah, another great topic. I think, when we have human relationships, we take that time to develop trust, and it's really important to look into how we can do that and not have to stare technology directly in the face. So thank you very much.
Thanks.
Okay, our third awardee is Dr. Kausa Gauscher Lambert, who is an assistant professor of mechanical engineering at the University of California, Berkeley, and an affiliate member of the Jacobs Institute of Design Innovation and the Berkeley Institute of Design.